The broadcast is now starting. All attendees are in listen-only mode.
Hello and welcome everyone to today's webinar. My name is Rishabh. I'm a marketing coordinator here at Struxoft Solutions, part of the Great Tech Group, and I will be your host for today. Joining us from the UK team is Natalie Hayward, our tech specialist, and Christopher Lightfoot, our technical project specialist, who will be walking us through using Dynamo scripts to streamline your workflows and exchanges between Revit and MWF. For those of us who are new today, MWF, which stands for Metal Wood Framer, is our flagship software that helps you automate and enhance the modeling and manufacturing of your timber and light gauge steel framing right inside the Autodesk Revit environment. Now, moving on to the webinar, please feel free to ask any questions that you may have during this presentation by typing them into the questions tab of the webinar dashboard, and we shall answer them once the presentation is completed. If you would prefer to ask your question verbally instead of typing it out, please feel free to do so once again after the presentation has been completed. In the GoToWebinar dashboard, you can raise your hand so that one of us can unmute you, and please do make sure that your mic is working correctly. And finally, I just wanted to let you know that the recording of this webinar will be available on our YouTube channel and our social media accounts, primarily LinkedIn, Twitter, and Facebook, by 5:30 p.m. EST. That is the end of the day for us. And that's it for me. I do hope you enjoy the webinar and find it informative. I will let Chris and Natalie take it over from here.
Hi everyone, my name is Natalie Hayward. In today's webinar, we're going to be looking at ways to improve your MWF and Revit workflows with Dynamo scripting. So we're going to be working with this model here that you can see, and with this model, we've got different zones in it detailed to different levels. Some parts are right at the start of the process and contain only architectural elements, and some are ready for sending to production, and some are somewhere in between. So today we're going to be taking you through the phases of an MWF framing project, and then looking at those phases and then using some Dynamo scripting to improve the process. As we work through each phase, we'll investigate how to optimize efficiency in the process, producing an accurate output for this project and all future projects. So this is where we're going to be utilizing Dynamo alongside Revit and MWF. So alongside me today, we've got my colleague Christopher Lightfoot. That's me there. I'm Natalie Hayward. I've worked with Struxoft for about 4 years now, and I'm a technical project specialist, and I've got a keen interest in Dynamo. And I will let Chris introduce himself.
Yeah, so hi everybody, my name's Chris. I'm a chartered engineer, an experienced Revit and MWF user, a technical project specialist here at Struxoft, part of the Great Tech Group, and like Natalie, a Dynamo enthusiast as well. So I think if you go to the next slide now, yeah. What we're going to take a look at today is, just as Natalie's mentioned there, we're going to go through 3 phases of a sort of standard MWF project, looking at the preparation phase, which is associated with the beginning of the project. It doesn't necessarily mean drawing the walls, etc., but it can mean interacting with the architectural model and just preparing your MWF templates and markers for their best and most efficient application throughout the beginning portion of the project. Then we'll move into the MWF framing side of things, the detailing part, and look at how we can use some scripts to help streamline some workflows and provide more clarity or more accuracy towards certain tasks. And then finally, we'll move towards exportation, which is going to be focused primarily on shop drawings, because they tend to be an area of the project that usually takes quite a bit of time on most projects. So we're going to look at some ways of improving that process.
Sorry about that. I've just realised I was speaking, I just realised I was on mute. So now we've moved into Revit. The first script we are going to look at will check the walls in our project. This script will aim to support the user during their assessment of the layers in multiple wall types. Ordinarily, at this stage of the project, MWF users will check the different wall types in the project by going into the wall properties and checking the wall structure. So I can just do that by grabbing one of the walls here and then going and looking at our wall structure. For successful framing in MWF, the user will need to ensure the structural layer is checked and as the structural material, and that it sits within the core boundary of the wall. There should be no other layers in the core boundary except for the structural layer, and the thickness should match the thickness of the structural framing member you plan to use in your panel. So this can be a time-consuming process when you've got lots of different wall types on maybe a mid-size or larger project. If you're working with a model intended for architectural purposes sent to you from an external collaborator, this process could involve quite extensive checking. The model we're working with today has over 20 different wall types, which I've just put in the side here, and they all require checking. I have updated most of my basement level of the model for MWF framing. However, I just need to check if I've missed any. So if any walls are not updated to the requirements that we've just talked about, MWF will not frame the panel and throw several errors. Or in some cases, it does frame the panel, but you don't get all the studs and the details that you're hoping to put in. So to sort of prevent this could require like just checking the panels in depth, updating the wall type, and then reframing the panels, which can add time to your framing project. And on larger projects, especially if MWF sort of partially frames a wall that hasn't got the correct layers, these panels can just be go completely unnoticed altogether. So what we're going to do now is I'm going to just head over to Dynamo. In our Dynamo player, I'm going to select a script which can sort of help me with this checking process. So this one here is called our structural layer review. Before I run the script, I'm just going to check if there's any inputs that I need to populate here. So I've just got the option of whether I want to reset the values, but because I haven't run anything yet, I'm just going to set that to false. So what I'm going to do is just run the script and then see what happens with our view. So now you can see that now we've run the script, it's highlighted some of our walls in blue. So I can see that these walls have been pulled out as different from the other walls. So I'm just going to click in here and then just have a look at why Dynamo's highlighted those. So I can see when I look at this particular wall type, it's got two structure layers within the core boundary, which would create problems for MWF. So what Dynamo's done is just flagged that for me, just shown me where in the model those walls are and which areas need correcting. Okay, so what I could do in the view now I've run this script is I could just go in, I could do select all instances or just update the wall types as they are and just make sure everything's organized properly. Alternatively, what the script has also done is it's populated a parameter which I can just see on the bottom left here called wall type layers, and from that I can go into a schedule. We'll just go over here. And in that schedule, I can just see as a high level on the project which wall types need addressing, and I can go in and just correct them here. Finally, once I've done that process, I could go just back to my view. And then I could reset the values. So to remove that, that colouring of the walls and just clean up the view again. Just give that one 2 seconds. Okay, and then again, once I've fixed my walls, what I could do is just rerun the script just to check that there's nothing outstanding there. So to conclude with that script, that's just helped me right at the start of my project to just make sure every wall is checked and ready for MWF framing. So now we're going to just go over and look at our wall joins.
Yeah, so the script we're going to look at now will aim to support the user during the assessment of their various wall join statuses. So ordinarily at this stage of the project, MWF users find themselves altering their walls and begin preparing them for both MWF templates and the application of their join markers. Placing join markers is a straightforward process. The auto join rule sets allow MWF users to instantly apply join markers following the user's prescribed join rule conditions, which Natalie's just going to show for us here on screen. So you can see we're using the auto join rule to just quickly apply a join marker. So there are some instances where users may apply or attempt to apply a join marker only to find that their marker either isn't placed, or at times it can even happen where you get an error, or sometimes just nothing happens. And it's those specific instances that we're going to take a look at here. So, you know, this form of error is not uncommon, and it's largely due to the join status of the wall within the project rather than an MWF or a user mistake related to join definitions. So what Natalie's going to do here is she's just going to give us a little example by selecting two of the walls in the internal part of this project here, which we would ordinarily assume that wouldn't get a join marker, just to try and tease out this error. As you can see, the wall is disallowed on one end. So when Natalie tries to use the auto join in this case, we're probably not going to get a join naturally, because the wall join status is disallowed. But there are times where that disallowed wall end can create some sort of confusion within the project. So disallowing walls is a common practice for the most part, as users may wish to disallow certain walls to simplify their framing design. Other times, however, disallowed walls may come from either adopted architectural content or inexperienced and unintentional design decisions. And it's that latter scenario that we want to aim to address with a simple demonstration to help the user spot these areas and give some more clarity as to where those instances are within the project. So in terms of a solution, in our case here, a simple solution would be to just make the user aware of these areas where the disallowed ends have been disallowed on the walls within their active view, so that they can decide whether further action is required. And with that, we'll take a look at the script that we've got here called end joins. That's the one. So this script doesn't really need any input from the user like the last one. It's there to serve as a sort of apply and retract the application, essentially. So it's a way of just controlling what the script actually populates in the project. And Natalie's going to go ahead and run the script now for us. I'll just give that a couple of minutes there to run. There we go. So as you can see, following the script, the view's now being populated with several red generic model families aimed at grabbing the user's attention and serving as a physical piece of content for us to track and to check. So additionally, albeit less noticeably, the script has also populated an instance parameter on each of the walls which have been flagged by the script, which we should be able to see on one of these wall types here that Natalie has selected in the properties. At the base there, we've got just a simple yes/no parameter just to serve as a way of tracking these instances. And this, combined with the schedule, ensures that the user has complete transparency on what the script has found within the project, once we've run it. So we should have a schedule here. There we go. And so you can see all the instances within the basement there that the script has found based on that parameter that was checked. So from here, the user may now choose to process these areas, which the script has identified, deciding whether the areas that the script has found are an error or whether they were just something that they were aware of and it's not too much of a problem. So one of those areas that's okay, let's say, is that first instance we looked at. Those two walls are joined in a butt join, so we wouldn't really need to apply a join marker here, and we can sort of safely say that the disallowed wall is correct in this case. We don't need it to be anything other. However, in the instance in the upper corner here, yeah, that's the one, you can see that there's no real need for these walls to be disallowed. Now, this might have happened for a number of reasons, but we might want these walls to be allowed because, of course, the main intention here is to spot areas where the join markers can be used so that they can automate those details that we want and save us some time. But what we're trying to spot with this script is areas where the walls have been disallowed and we haven't accounted for those instances. Maybe they've been produced through errors or they've been produced through content, etc. We're looking for those instances, and that's what the script has found in this case here. So once the user's finished with their review, they may choose to run the script again, this time to remove all of that clutter, all of the generic model families, and also reset those parameters as well. And we'll just run the script here and I'll get rid of those. Great. So to conclude, this script, while simple, has provided the user with some much needed control and perspective associated with this particular workflow. Using the script, we've been able to identify areas which may have been otherwise overlooked, and this has allowed us to be more efficient with our MWF and our join marker application. And that will do it for the preparation phase. So the script's aimed at supporting us during those early stages of the project. So now we're going to move into some of the more detailing based tasks. So when we're partway through the project, when we're beginning the framing of the various elements of the project. So with this script, we're going to be looking at joist racking. And the script in particular is going to help us support the user during the process of modeling joist racking. So as you can see, we have a small area of the project here currently being populated with some MWF floor joists. Users occasionally require floor joist racking within their floor systems, which we're going to take a look at modeling now. Racking members themselves within floor joist systems are not uncommon. The racking members themselves are usually just loose pieces of material which are installed across the joist system and usually attached to the joist webbing. And what we're going to demonstrate here just to begin with is what that process looks like manually. So Natalie's going to go ahead and drop in some framing, and we're just going to sort of exaggerate it a little bit here so that she can access the ends of the framing and disallow those ends and trim the member up to the first and the last joist in that joist run. Symbolizing that that's the overall length of the joist racking, and from there we've just got to position it within the joist system, and then we can just simply copy and paste. So we're getting that first piece here just trimmed up. Once it's trimmed up, we've got the confidence to then copy and paste and go to a side elevation view of the truss so we can see the webbing. There we go. So now it's just a case of moving the member into sort of the center of the joist that we've got modeled here. So just aligning it to the heel, and then we're going to copy and paste it through all of the various pieces of vertical webbing within our system here. And there's an element of accuracy that's required here. We don't have to be too particular when modeling these things in the sort of real world, but we just need to make sure that the quantities are right. So it's not too much of a problem for us if they're sort of clashing a little bit with some of the diagonal members. The idea is that we want to provide the required detail, which is to provide the right number of these members and the right length of these members so that we can decide maybe on site how and where these are going to go. But obviously, if we can extend some of the design capabilities that we've got here, the accuracy within Revit and with MWF, then that's always going to be beneficial. So as we copy these through these sort of pair of joists, we know that the racking members themselves are the right length, and that's pretty much the process. So as we've seen from that demonstration, there is some room for error, and the task itself is also quite repetitive and quite predictable. On a project of this size, even this small section of the project could take around 30 minutes to model, but modeling the content is only really half of the task. We'd also like to be able to schedule these members to understand how much material overall is required within the project. And it's that second part that makes this a little bit more complicated, increasing both the chance of human error and the duration of the task, because we now have to go through and sort of start tagging these members so that we can keep an eye on it. And as Natalie's demonstrating here, there's also that element of human error that can occur. So naturally, we're going to want to try and use something that we've just modeled, 5 minutes beforehand, as many times as we can in the project, and sometimes that can create oversights like this. So whilst we've copied and pasted the joist racking to the next room, maybe the numbers aren't quite right, the lengths aren't quite right, they're not matching up with the system that's there, and that's really what we want to try to address here. So with all that context, what would be an appropriate solution? Well, modeling and manually tagging each of these joist racking members is a simple enough task, but as the project gets bigger, so too does the detail of modeling the joist racking members, tagging them, and most importantly, maintaining that frame in detail should revisions happen. So if we were to ask ourselves, how could we make this process more efficient for the user? A simple answer would be to simply remove some of the chance of human error and reduce the amount of time needed to complete the task. So with this, we're going to take a look at the script that Natalie's got open here. As we know, this area has been currently populated with the joist racking and the trusses. So what we can see is as we work through this area, as we've refined the selection to just two things. That's all the user gets to work with. And so we've simplified this process quite a bit for them. So they only have to select the first truss and the last truss. And then from here, we can just run the script. Okay, so within a few seconds there, the script has sufficiently identified the type of framing members being used in the selected joists and has proceeded to model the joist racking members. Each racking member is modeled to the side of the vertical members, and each of them has their various offsets and tolerance applied so that there's no overlaps. What's more, each member has been stamped with a simple comment value, allowing the user to schedule these specific members later. So, as Natalie works through a few more of the rooms here, I'll just kind of go over the sort of summary here. So, once we've got a few of the rooms modeled, we're going to take a look at a schedule just to kind of see what's being tracked in the background. But you can see the process is a lot more straightforward for the user. There's no real need to maybe work in different views. You can achieve this task with just a simple 3D view. As long as you can see the first and last joist in your area, you're going to be able to model these members. And as I say, the most important part is the problem we've tried to solve here is making the task not just simpler, but faster as well. We can now say that this task is sort of faster than the raw modeling process and can help us to avoid that urge to do the copy and paste from room to room or from area to area within the project. So once Natalie's done this next room, we're going to take a look at the schedule that's just been running in the background, keeping track of all the members that we've been producing through the script. So if we've got that schedule to hand, it's just a simple text parameter that's being populated as well within the joist racking. So you can apply it to any real value. We've just used the comments value for the minute. But you can see here we're starting to get a running sort of quantity on how much overall is within the project and how much within each sort of section of the project. So we can see a common trend there of a 4 meter length. So to conclude, overall, how has this script helped our user? Well, This script, when compared with the standard modeling process, has reduced the chance of error and has reduced the amount of time needed to complete the task. The process using this Dynamo script is both easier and faster for the user. And with that, I'm going to hand over to Natalie, who's going to take us through some more detailing associated Dynamo scripts that can help our MWF users.
Apologies, I've just got to stop putting myself on mute because I can't remember to take myself off mute. But we are now going to look at how we can use Dynamo to speed up the application of placing a corner brace into our wall panels. You can do this within MWF, but there is no specific tool for adding a corner brace within MWF. It can be done within the K-bracing tools of the panel properties. However, it's difficult to save your settings to a template, as this can cause problems if you've got panels with joins or openings. So when you've got a model of this size where there's about 180 panels on each level, applying this edit on a panel by panel basis, or like just with a couple of panels at a time, can be quite a repetitive and slow process. So what I'm going to do is I'm just going to look into a slightly more zoomed in view so we can just work with a couple of walls at a time. And the first thing I'm going to show you is how we would add a corner brace within MWF. So I'm just going to get familiar with some of the members that are within this panel, just to check if there's any join studs or anything like that. And then I'm going to head over to my panel properties. Okay, so I'm going to go to our K-bracing tool. And this process is quite similar to just adding a K-brace. However, we're just going to edit the height and the clearance from the end stud. So we're just going to make that height a little bit smaller. And then we're just going to give it a name and add it to our panel. And we'll just let that process within our panel. And really, that is a fairly smooth process. However, there's a couple of maybe 5 different things that you've got to consider within that. And when you're working with like hundreds of different panels, it can be quite time consuming, and also it's open to sort of errors, like whereas if the stud next to the stud that will have a corner brace is a join stud, then sometimes MWF will ignore this and just go to the next stud. So then you have to sort of go back into the properties and rework it. So it's not a difficult tool, but I think it's just if you're working with a large project, you can there are sort of risks involved in it. So within that context, what would be an appropriate solution to this? So adding a corner brace through MWF, it could involve checking each corner brace and just maintaining their position as panels are regenerated throughout the project. If we were to consider how to make this process a bit more user-friendly, it would be to automate some of the user-controlled variables and allow the user to edit across multiple panels with different framing conditions. So you can see now this is what the corner brace looks like when you add it within the MWF properties. What I'm going to do is I'm just going to head over to one of our internal panels here, and I'm just going to show you the process of running our script. So I'm going to go to the corner brace and just have a look at the user inputs. So there's a couple of user inputs here. You've got the option of where you want to start your corner brace from. So I think we're going to start here at S1. We're going to create a corner brace, and then we're going to select our panel. And now we've got all our inputs, we're going to run our script. Okay, so we've run our scripts, and at the moment I can't see any changes within my panel. So to see those changes registered, I'm just going to regenerate our panel. Give that a couple of seconds. And when we've been looking at the inputs, you can see we can simplify the process for the user by just reducing the number of inputs. Like when we've selected it in Dynamo, all we need to do is identify the startmost member and choose whether to create or delete a corner brace, and then select the panel we wish to create a corner brace for. So so with this, it sort of gives you, as long as you're working with a corner brace that's starting at the same member for multiple panels, it will allow you to sort of apply the corner brace to multiple panels in your project. So this could save you quite a lot of time in your framing process. So with that, you can see that the corner brace is successfully applied to our panel. So one more thing you can do with this script is you can use it to delete your corner brace. So we're going to just have a look at that. But in the meantime, if it was to create my corner brace, but I actually wanted some of those additional inputs, what I could do is go into my panel properties. And then when I go over to my K-bracing, you can see all of those settings have been saved within the K-brace, so I can make additional changes to that corner brace if I wanted to. So the last thing I'm going to do is I'm going to just get rid of this corner brace just to show you the process of that. So that could happen maybe if you had accidentally selected an extra panel when you're applying this on multiple panels and you just wanted to get rid of it. You just wanted to take it off that particular panel. So we'll give that a couple of seconds to run. And when that's run, I'll just need to go in and regenerate my panel again for my changes to register. So as this is running, I'm just going to conclude this. So to conclude, I'll just let that regenerate so we can see see those changes in action. So this script has sort of helped my user experience with the script both simplifying and clarifying the standard modeling process and allowing the user to make a mass edit across multiple panels. The process of using this Dynamo script has significantly reduced the time spent on needed to spend on the detailing process. Okay, so just give that one a couple of seconds. And once we see those changes applied to your panels, what we're going to do is we're going to we're sort of just going to conclude our detailing process and start to move into our quality assurance and exportation process. So the next script that we're going to look at is sort of going to be a little bit of like checking on the framing, but allowing you to do additional detailing if needed. So we'll just give that a couple of seconds, and yeah, that one's applied. So let's go over to our QA script, which will it's just going to check some of the walls in this view. So what I'm going to do is I'm going to I've got these walls these panels hidden. I'm just going to show them in my view. This might take, in fact, that might take a little while. So I'm actually just going to go in to the hidden view just so you can see that these panels are framed. We've got them all framed fully. We've got our joins in, and some of them have opening markers. When I'm doing this checking process, I'm not going to be including my external panels because they all have an opening framing map put into them, so I don't need to check to see if they've got a marker applied. However, with my internal panels, I've been using the opening markers. And you can see here, some of them have got that opening header already put in. But if I just go over to this one hasn't. And if we just head out of this view, you can see there is a lot of panels here in the view. So if I was just to do this process manually, I would just grab one of these openings here and go to apply opening type. And I could see that a marker was applied to that. For multiples, I could just select all instances. And again, I can see that mark has been applied all over for all of those particular openings. However, if I was just to grab this opening, I could see that this one hasn't got a marker applied to it. So what I can do is I could go around door by door, or if I had maybe only a few different door types, I could go in and just select all instances and just check that. But in this case, I think we might have 6 different door types. It's a bit of a long-winded process, and also it could allow you to miss some doors. So what I'm going to do is I want to identify a solution that's just going to help me highlight where in my model an opening marker has been missed or hasn't been applied. So I'm going to my contains opening marker script here. I'm just going to check if we need to add any inputs, and we don't need to add anything for this particular case. So I'm just going to run the script. And what you can see that has happened here is some of my walls have been highlighted in pink. So what I can do now is I can look at these walls and I can go over to markers and apply opening type, and I can see what the script has done is identified where an opening marker hasn't been placed. So now I know in my project where to look to find the openings that need a particular marker. And also this is quite useful if you're not applying the same marker for each door type. So you might need to go around and look on a more individual basis. So now that's been highlighted for me, I can go around, and this is sort of useful in the process where you've already framed your walls and you're looking for that final sort of checking and adding the final details to your projects and just making sure everything looks okay. So yes, to conclude that script, it's just sort of assisted me with that checking process and also saved me a little bit of time from going around and checking every single opening type. So with that, I think now we're just going to look at our final script, which is going to focus more on our exportation phase in the shop drawing, detailing.
Yeah. So in this final phase, yeah, we're going to do exactly as Natalie's just said. We're going to look at ways to support the user throughout the data population and detailing process associated with shop drawings. So as you can see, we have a large area of the project currently being progressed towards the manufacturing handover. This includes producing individual panel shop drawings using MWF. Once the shop drawings are created, a typical workflow for the user may include initially checking the content of the sheet, of course, for any general errors, followed by populating various forms of information associated with the panels. And some of this information may be represented within the title block family, or it could be possibly additional annotation and views added to the to the sheet for further clarity. This is an area of the application of MWF that varies quite a bit from client to client. Some people put a lot of detail on their sheets, some people don't. Certain sheets need extra pieces of annotation, some don't, etc. But what we're going to do here is to demonstrate a typical workflow, or what a typical workflow could involve. We could say it could be populating a drawn status, as well as other forms of panel data, such as the material type being used, the length and height of the panel, possibly the weight and the area of the panel. And some of this information can be extracted from the project using schedules. So what Natalie's going to do here is she's just going to show you how we could just kind of manually populate some of that information based on this sheet that we've got here. And obviously, if we've got a Revit schedule in the background, that could be counting up all the bits of panel data using, let's say, the wall or something, or the individual framing members. So things like the E1 stud or the bottom track stud. We could use those to kind of pull out the top and bottom heights and lengths. Things like the weight, we'd have to probably calculate a little bit with the Revit schedule, but the idea is that a lot of that information is obtainable through a project schedule. It may also be a requirement to provide panel-specific information, such as different instructions for the manufacturing team if the panel has certain conditions, such as openings or bracing. These instances may require different fixing requirements or even supporting illustration. So with this panel here, we can see it's got an opening. So we could say that the fixing note for this panel is non-standard and that the panel is for review. So what Natalie could do is she could write some sort of note into the fixing requirements area to simply inform the manufacturing team that they need to do something a little bit extra with this panel. It's not a standard panel because it has that opening, it has that condition that we're looking for, and we could flag that as something for review. So again, some of that information may be extracted from the project in the form of a schedule, but as we can see that it could become more difficult as the connection between the information and the panels becomes harder to establish. It's not really easy to associate a panel that has an opening from a panel that doesn't have an opening, given that within Revit we can simply schedule the panel labels, or we can schedule the walls, or we can schedule openings, but these three things independently don't really communicate to each other. So some of that information is a lot harder to extract. So some of those conditional notes are harder to extract. And that's where we find users can spend quite a lot of time just sort of chasing the connections between that information. So, as you may have guessed, while detailing these few shop drawings here only takes a few minutes, detailing the whole floor or even the whole project could take a lot more time. Those connections could take a lot more effort to create. What's more, a lot of the information which was populated was already known in one format or another. It just wasn't accessible, forcing the use of this slow and error-prone workflow. And with that context, what would be an appropriate solution? There are several strategies that you can use and techniques that can be used to make this task a little bit easier while detailing the shop drawings. The use of schedules, as I've mentioned, and also batch selection can help the user when populating the data, but these methods still do carry some element of human error. Not to mention, if a panel is revised, then managing and repeating this task also becomes a concern. So to put it simply, a solution in our case here would be to reflect the information which is known about the panel into relevant areas of each drawing with as little human input as possible. This would streamline the workflow and reduce the chance of error. And with that, we're going to now take a look at our final script here, which is the shop drawing data population. So as we've seen previously, detailing a few sheets is not too bad. However, for this demonstration, we've restricted the script to only work on a few sheets just to save a bit of time. We're now going to run the script. This script has a few text inputs for the user who may specify drawn status, as I mentioned earlier, a standard fixing note or an exception fixing note. In our case here, the script is designed to provide the exception note to any panel that has an opening. We've also included a reset button to give the user additional control. And with the variables populated, we can now run the script. We'll give that a couple of seconds to run. And once that's finished, we can begin to inspect the results. And we'll just initially focus on this sheet that Natalie's got open here in the background. But yeah, the idea is with this script is we're trying to cut through some of that detailing process, create connections between information that's not readily accessible. So as I mentioned before, understanding whether a panel has an opening, it's not something that's really extractable from the panel itself. It doesn't really know that it has an opening unless you want to start querying whether it's got a K1 stud or some form of king stud, BIM-SF label in the stud families. And this is a bit of an irritating connection that's missing, because we know with Revit elements like of windows and doors, they are hosted to the wall, and the wall can essentially be used as a way of interpreting whether a panel has that information or doesn't have that information. But likewise, there could be other conditions. So we're focusing here on something simple like openings, but there might be a condition where, let's say, you have a specific framing detail within the panel. So, you know, let's say if it's got K bracing or it's got some form of flat plate bracing, you might want panels that have those details to be provided with a different note or a different detail. And that's really what this script is aimed at solving. It's there to provide the user with an option to kind of cut through some of that process and reduce that the sort of manual population task, and ultimately save time, because it's this back end part of the project when shop drawings are being detailed where we see the most time being spent on projects. So now that the script is finished, it's processed, you know, these 30 or so sheets that we've got in the project in, you know, roughly about the same time as it would take to thoroughly detail one or two. As we can see with the script has populated all of the same fields we populated in our earlier example, including the status, including the fixing note, and the panel data. So we can see the length, height, area, weight parameters all being pulled out there and populated within the sheet. The script has also highlighted some manufacturing warning statuses on the sheet as well. It's done this by checking the panel's data against some predetermined global parameters, which in our case impose some manufacturing and transportation limitations. And we can see on this sheet, the fixing note reflects that exception I mentioned earlier. And as this panel has an opening, the fixing note is different. So we can see it's saying extra fixings to opening header and kings there. We can also see that this panel is both oversized and overweight, so possibly requiring some additional coordination between the design and manufacturing team to make sure that the panel is handled safely or transported safely. And finally, this sheet is also an external panel, which was a condition I didn't mention at the start there. All exterior panels in this project require a detail to support the exterior panel manufacturing process. So in our case here, we've just got a simple detail that's been applied to the lower corner of the sheet. So as Natalie sort of skims through a few of the sheets, I'll just go ahead and summarize what we've concluded here. So to conclude, this script has allowed us to tap into some known information about the panels and presented that information sufficiently on each sheet. It's achieved this using a more accurate and faster workflow than that of the typical workflow demonstrated earlier. And overall, the application of a script like this can reduce the time taken to detail shop drawings while also reducing the chance of error. And that will do it from me.
Okay, well, thank you very much, everyone, for attending the webinar. That's everything that we've got to show you today. And with that, I will just hand you back to Rishab.
Perfect. Thank you for the presentation. And as Natalie says, we will now open the floor for your questions. And I do see that we already have one from Jamie Hine. And it goes, are these scripts going to be available to download? So I think Chris or Natalie, I think these are available on the website. Is that correct?
I think they're going to be formatted before they go on the website. The direct copies from this webinar won't go straight on there because they've been sort of tailored a little bit to help us, with the sake of the webinar, not take too long. But yeah, I think there is intentions to put these and similar scripts up there on the website for download. I think we've just got to work through the actual presentation part on the website. So yeah, I think they will be, but I don't know exactly when.
Perfect. So we have the second question is kind of similar. How do we get access to these scripts? So yes, once these scripts are available for the public, then we will be revealing them on our social media. So for now, we don't have access to them. But once that is there, we will be notifying the users. And having said that, we will wait for, okay, we have some more questions. Is it possible to create a script to add horizontal blocking between the closest studs to a wall joint? So I'll let two of you answer that.
So to add horizontal members between, what was it, sorry?
So is it possible to create a script to add horizontal blocking between the closest studs to a wall joint?
So like a ladder join, or obviously you have the end of the panel, then you have a join stud. I know that there's a ladder join marker that we have within MWF that will put a horizontal rule between those two members. Is it the next member after the join stud that we're talking about in that context? But overall, I would say to a degree, yeah, there are ways to tap into certain parts of an MWF panel and manipulate something that's there, or add something as Natalie's shown with the corner bracing. So in that context, we've kind of been working around some of MWF's functionality, the K-bracing portion, to try and provide a slightly different detail. As we discussed with that script, there isn't a tool or a function within MWF right now for corner bracing. So you can see what we've done is we've taken a portion that can do the detail and made the application process simpler for the user, so that it isn't so manual and you don't have to try and guess the numbers, and it can work in a more repeatable manner. But yeah, I would say for the most part, the only limitations that I know of with Dynamo and MWF is, first of all, the application of Dynamo works primarily with the wall module. And it also only works with the single layer portion of the wall module. So if you're working with multi-layer, unfortunately, multi-layer does a sort of final coat of gloss on anything before it's regened, and that will just sort of overwrite anything that a script has done. But there are still ways to use Dynamo within your MWF projects, as we've demonstrated. You can use Dynamo at that front end part to help prepare your project. You can use Dynamo at that back end part to help you get through the shop drawn part. And even the pieces in the middle, we've sort of worked through with the corner bracing and such, and the open checking. We've still accessed parts of these panels and drawn out bits of information to help us get through those processes. So as Natalie demonstrated with her opening marker portion, it's very easy to say that you've applied, let's say, an opening map rule that's done the job of applying all the opening framing conditions, but then you've had to manually apply certain extra opening markers. What her scripts demonstrated is a way to find those markers, report upon them, and maybe provide the user with more information about it. So I would say it's possible, yeah.
I'd say if anyone's interested in sort of like exploring, like they've got an idea and they'd like to explore that in Dynamo, just like reach out to us, because it'd be great to talk about those things.
Yep. And I see that we have another question. Are there plans to include these Dynamo scripts within or with the MWF installation?
Again, very possible, yeah. I think if they are going up onto the website, then you've obviously always got access to them there. But I wouldn't say that it's impossible to put them in there, as well as a sort of pre-baked set of common scripts that are somewhat reliable. I think if if they do get quite a lot of good feedback, it's likely that they'll probably just be hard coded into MWF if that's something that our users are interested in. But yeah, I would definitely not rule that out. It could be a potential.
I hope that answers your question. And we have a question from Ewan James. Could you use Dynamo to run clashes between walls and internal components to place marker lines to create fixing blocking members?
Yeah, so I've done similar concepts in the past, trying to work with a similar sort of concept, and I think it's a maybe. It's a solid maybe, because I know that you can use Dynamo to identify these instances. In my scenario, I was trying to use Dynamo to place MWF stud pack markers, and that was going to be generated based on maybe where point loads within the building are, or maybe it's where grid lines intersect, walls. The idea being that there's a point that can be obtained from a wall, and we can convert that into the placement of a family. And so it's a similar sort of concept. You're looking for something within a wall, something that's clashing, and you want to produce marker lines. So I think the where it's a maybe is we'd have to look at what MWF needs from the user and how we can give that to MWF in the same format that MWF would have accepted if it had done the task. So I wouldn't rule it out, and it would definitely be a cool one to take a look at. And as Natalie mentioned, maybe that's one of those ones we can take a further discussion offline.
Perfect. So I do hope, once again, that answers your question. And while we're waiting for any more questions to pop in, I would just like to remind you that the recording of this presentation will be posted on our YouTube and social media channels, primarily, once again, LinkedIn, Twitter, and Facebook. So I do invite you, while you're at it, to please feel free to subscribe to our social media channels and to like them and follow them, as we do post regular updates about our company, blog posts, and tech tips for your benefit. There's a question from Jimmy Hine. Can Chris add his email so we may reach out to him? Yes, indeed, Chris, if you feel free to add your email, but also we will be revealing our contact details in a recording email that will be sent out to you once our sessions are completed. So we will definitely be reaching out to you. But Chris, do feel free to share your information.
Yeah, I think, as you say, if it's going to be included in the follow-on emails, it'll be there. But if not, I'll send it out. Yeah, that's no problem.
That's perfect. That's okay. I'll reach out to Jamie personally. I'll just send the required information. And all right, so we will just give a couple more seconds for any more questions to come in. Okay, that looks like a wrap for today. So thank you, everybody, once again for joining us. If you had any further questions or required any further clarifications, then please do feel free to reach out to us. And as I mentioned, our contact details will be provided along with the recording tomorrow via email. And if you would like to have a one-on-one demonstration or a training with one of our experts, we will be happy to set that up as well. And again, thank you for joining us today. We do hope you have a great day ahead.